The Hubble Space Telescope has been orbiting Earth for over 34 years, and its mission has been nothing short of extraordinary. Although it wasn't initially built to study objects within our own solar system, Hubble has consistently managed to do just that. Over the course of its journey, it has captured remarkable events that might have otherwise gone unnoticed. While not every planet has its own dedicated mission, there is a vast array of celestial wonders beyond just the planets. So, let's embark on a journey through our solar system, traveling from Earth to its farthest reaches and uncovering fascinating objects through Hubble's sharp and revealing gaze. Our first stop is the Moon, Earth's closest neighbor. Due to the Moon's large apparent size in the sky, Hubble is unable to photograph its entire surface in one shot. Additionally, other missions, such as NASA's Lunar Reconnaissance Orbiter, are better suited for detailed lunar imaging. As a result, Hubble's valuable observing time is typically used elsewhere. However, in 2012, it played a key role during a special astronomical event, Venus passing in front of the Sun. During this transit, scientists used the Moon as a massive mirror to study how sunlight filtered through Venus's atmosphere, revealing details about its chemical composition. Although Venus's atmosphere is already well known, this experiment helped test the accuracy of light-scattering methods that Hubble now frequently uses to examine the atmospheres of distant exoplanets. Because the Sun is too bright for direct observation, using the Moon as a reflector allowed researchers to gather essential data. Unlike the Moon, Hubble is well-equipped to observe Mars and often provides a complete view of the planet's disk, something orbiting spacecraft can't always do. These images offer critical insights into Martian dust storms, seasonal shifts, and other atmospheric phenomena. This information plays an important role in planning rover missions and predicting weather on Mars. In one notable time-lapse, a global dust storm can be seen swallowing the planet, masking its surface. Meanwhile, Mars' two small moons, Phobos and Deimos, whirl rapidly in the background. Their quick movement is particularly visible in a 42-minute sequence. Another short time-lapse captures Phobos alone, completing part of its orbit in just 22 minutes. This tiny moon orbits Mars in only 7.5 hours, making it the only known moon in the solar system to orbit faster than its planet rotates. As we move past the rocky inner planets and approach the realm of the gas giants, we encounter the asteroid belt, home to countless intriguing bodies. Among them is asteroid 6478 Gault, a puzzling object that looks like a comet because of its twin tails. Despite its appearance, Gault is in fact an asteroid, located within the main asteroid belt and first imaged by Hubble in 2019. The presence of its tails is likely due to the Yarkovsky, O'Keefe, Radzievsky-Paddock YORP effect, a phenomenon in which solar radiation gradually speeds up the rotation of small, irregularly shaped objects. In Gault's case, the 3.5-kilometer-wide asteroid now spins so fast, once every 2 hours, that centrifugal forces have begun flinging loose material into space, forming tails. This rapid rotation is near the upper limit of what an asteroid can withstand. Like many small bodies in the belt, Gault is not a solid mass but a fragile rubble pile held together by weak gravity. Eventually, it will likely break apart completely. The asteroid belt is far from a quiet place. It's estimated to contain between 1 to 2 million objects larger than a kilometer, along with countless smaller fragments. One particularly rare event observed by Hubble involves the object P/2010A2. At first glance, it resembles a typical comet, but closer inspection reveals an unusual X-shaped debris pattern near its core. This is not a comet's nucleus, but rather the aftermath of a collision between two asteroids. The impact expelled rubble in 4 directions, forming a structure unlike any seen before. Some of this debris remained nearby due to weak gravity, while other particles escaped entirely. Although collisions like this are rare, most asteroids continue to orbit the Sun in stable circular paths. However, if one veers off course like a comet might, it risks coming under the influence of a far more massive object, Jupiter. Often referred to as the solar system's vacuum cleaner, Jupiter dominates this region with its immense gravity. Containing nearly 75% of all the matter outside the Sun, its gravitational force shapes the orbits and destinies of many nearby objects. One of the most dramatic examples occurred in 1994 when comet Shoemaker-Levy 9 strayed too close to Jupiter. The planet's gravity captured and then tore the 2-kilometer-wide comet into multiple fragments. By the time these fragments struck the planet, they were widely dispersed, creating the first-ever directly observed collision between extraterrestrial bodies. Remarkably, the comet had been orbiting Jupiter for about 20 years before its final encounter. Its last close approach subjected it to tidal forces strong enough to break it apart. A year later, the pieces slammed into Jupiter at speeds exceeding 60 kilometers per second, over 210,000 kilometers per hour. The impacts created enormous fireballs over 23,000 degrees in temperature, some of which rose more than 3,000 kilometers above Jupiter's atmosphere. The most powerful impact left a dark spot the size of Earth and released energy equivalent to 6 million megatons of TNT, over 600 times the combined yield of all the nuclear weapons on Earth. While most impacts are less extreme, they've been observed and documented, supporting the idea that Jupiter protects the inner solar system by absorbing or deflecting potentially dangerous objects. But Jupiter offers more than just gravitational might. It's also home to some of the solar system's most captivating atmospheric phenomena. For example, Earth isn't the only planet with auroras. Though Earth's auroras are visible to the naked eye, they're brightest in ultraviolet light. Hubble's ultraviolet capabilities have allowed astronomers to study these lights on other planets, particularly Jupiter, whose auroras are the most intense. In 2016, during the Juno mission's approach to Jupiter, scientists took the opportunity to monitor how solar wind affects the planet's auroras. With Hubble observing nearly every day for several months, researchers discovered that Jupiter's auroras are hundreds of times more powerful than Earth's, with radiant power reaching 100 terawatts. Unlike Earth's auroras, which are sporadic and tied to solar storms, Jupiter's are continuous. This suggests that Jupiter's auroras are powered not just by solar wind, but also by charged particles from its intense radiation belts. These particles follow magnetic field lines into the atmosphere and alternating electric currents within the field, rather than direct currents, are responsible for the energy that fuels the auroras. This kind of energy transfer doesn't happen on Earth, making Jupiter's auroras uniquely powerful. Turning now to one of Jupiter's most mysterious moons, we arrive at Europa. Despite the vast distance, Hubble has captured detailed images of this icy world. Europa is one of Jupiter's largest moons and is considered one of the best places to look for extraterrestrial life in our solar system. Not on the surface, but beneath it. Scientists believe Europa harbors a global subsurface ocean of liquid water beneath its frozen crust. The immense gravitational pull from Jupiter creates tidal flexing, which produces internal heat. This heating may be enough to maintain a warm, liquid environment beneath the surface, potentially providing the necessary conditions for life. Europa's icy surface may conceal a subsurface ocean kept warm enough to remain liquid. Over the years, various space missions have tried to confirm the existence of this hidden ocean, and the Hubble Space Telescope has played an unexpected yet critical role in the search. While earlier spacecraft such as Galileo and Voyager provided close-up, high-resolution images of Europa, they lacked the capability to detect ultraviolet light. Hubble, on the other hand, detected what appeared to be plumes of water vapor erupting from Europa's surface. If these eruptions are confirmed as volcanic activity, they would be strong evidence for a liquid interior, further supporting the idea of an underground ocean. Since the initial findings, many more plumes have been observed, strengthening the case for this remarkable subsurface sea. Hubble has also contributed to identifying the composition of Europa's surface. Unlike most missions that use infrared imaging to study planetary surfaces, Hubble's ability to observe invisible light allowed it to detect sodium chloride, common table salt, on Europa. Since salt primarily shows up in the visible spectrum, previous missions like Galileo, which relied on infrared, missed this key detail. The discovery of salt deposits on Europa suggests they originated from the underground ocean, likely carried up by the water plumes and left behind as residue. The presence of sea salt is exciting because it hints at the possibility of hydrothermal vents on the ocean floor, environments known on Earth to support thriving ecosystems. However, sending a mission to explore Europa's deep ocean remains a goal for future decades. Moving on to Saturn, our exploration continued through the lens of the Hubble Space Telescope after the Cassini mission concluded in 2017. With no active spacecraft currently orbiting Saturn, Hubble remains our best tool for studying the gas giant. Hubble regularly monitors the planet, observing changes in atmospheric weather and seasonal patterns. Cassini only observed Saturn for half of one Saturnian year, so Hubble now fills in critical gaps in our long-term understanding. Among its most dramatic observations are enormous storms stretching thousands of kilometers across the planet. Beyond its scientific achievements, Hubble has also delivered stunning images that capture Saturn's immense beauty and dynamic atmosphere. As we turn to Uranus, the first of the ice giants in our tour, we find another fascinating and often overlooked world. Like Jupiter and Neptune, Uranus experiences massive storms and displays brilliant auroras near its magnetic poles. Uniquely, Uranus's magnetic field is misaligned with its rotation axis, which itself is tilted so dramatically that the planet appears to roll along its orbit. This unusual tilt makes events like solar eclipses caused by its moons extremely rare. The first documented instance of a moon casting its shadow on Uranus occurred in 2006, as prior alignments predated advanced telescopes capable of capturing such phenomena. During that rare eclipse, Hubble captured the moon's shadow on Uranus's surface and detailed images of its atmospheric bands. Since then, Hubble has continued to track Uranus over its lengthy 84-year orbit. Observations have shown that when one of Uranus's poles tilts toward the Sun, a bright cloud cap forms in the summer hemisphere. This cap gradually fades as the planet approaches equinox. Since Hubble has only been active for 34 years, we've seen less than half of a Uranian year, meaning there is still much to learn about its changing seasons. Now let's examine one of Hubble's most remarkable contributions to our understanding of Neptune, the discovery of its smallest known moon, Hippocamp. Before Hubble, this moon was entirely unknown, and without its observational power, it might have remained so. Despite being largely overlooked by space agencies, with only a single flyby by Voyager 2 in 1989, Neptune has revealed fascinating secrets through Hubble's watchful eye. In 2013, Hubble spotted a new moon, later named Hippocamp. While many moons have been discovered around other planets, Hippocamp is significant because it may be a remnant of Neptune's larger moon, Proteus. Proteus, about 400 kilometers wide, shows signs of violent impacts, with craters up to 100 kilometers across. One such impact likely broke off a piece that became Hippocamp, a small, irregularly shaped moon about 35 kilometers long, now orbiting close to Proteus. This discovery adds to our understanding of Neptune's dynamic history and the ongoing evolution of its satellite system. Looking more broadly at Neptune, Hubble's continued monitoring has shed light on its turbulent atmosphere. Although not originally designed to observe the solar system, Hubble began dedicating more time to the ice giants in 2015. This shift enabled yearly observations that have helped track seasonal atmospheric changes. Neptune is known for its enormous storms, such as the Great Dark Spot spotted by Voyager 2 in 1989, a massive storm similar to Jupiter's Great Red Spot. However, unlike Jupiter's persistent storm, Neptune's have proven to be temporary. New storms form and vanish over time, with the most recent major storm observed in 2018 now thought to have dissipated. Scientists believe these fleeting storms are caused by atmospheric bands moving at different speeds, creating vortices where they interact. These storms drift across the planet until they lose energy and break apart. Hubble remains the only observatory capable of monitoring these changes, as the storms are nearly invisible in most wavelengths of light. Fortunately, Hubble's ultraviolet vision gives scientists a valuable window into Neptune's weather patterns. As our journey through the solar system draws to a close, there is one more remarkable discovery worth highlighting. While Pluto often takes the spotlight, another distant dwarf planet named 2007 or 10, or Gonggong, deserves attention. Despite being the third largest dwarf planet after Pluto and Eris, Gonggong remains unfamiliar to most. Like its counterparts, Gonggong lies far out in the Kuiper Belt. Although Hubble didn't discover it, the telescope helped reveal that Gonggong has a moon. This moon went unnoticed in earlier images because it was too faint. Scientists only suspected its presence due to Gonggong's unusually slow rotation, It takes around 45 hours to complete a full spin, much longer than the typical 24 hours or less for most Kuiper Belt objects. Researchers hypothesized that a moon's gravitational drag was responsible. Revisiting old Hubble images confirmed their suspicions, showing that Gonggong does indeed have a moon. This finding adds to a growing pattern. Nearly every known dwarf planet in the Kuiper Belt has at least one moon. This may be due to the relatively gentle collisions that occur in this distant region of the solar system. Unlike the asteroid belt, where high-speed impacts send debris flying into space, objects in the Kuiper Belt move slowly enough that fragments are more likely to stay gravitationally bound, forming natural satellites. Gonggong's moon adds a valuable piece to the puzzle of how solar system bodies form and evolve. Reflecting on all these discoveries, it becomes clear how crucial the Hubble Space Telescope has been in expanding our understanding of the cosmos. Over the last 30-plus years, Hubble has accomplished far more than anyone originally imagined. Its observations have revealed everything from hidden oceans and moons to dynamic weather systems and mysterious new worlds. Even more exciting, Hubble's mission isn't over. With continued maintenance and support, it could remain active until around 2040, possibly outlasting its successor, the James Webb Space Telescope. If you found this journey enlightening, be sure to share it with fellow space enthusiasts, give it a thumbs up, and subscribe for more astronomical discoveries. And as always, keep your eyes on the skies, because the universe is full of surprises. Until next time, stay curious.